Hello, my name is Roya. I'm working at National Physical Laboratory, and today I talk to you about a smart textile. Within NPL, we developed a technology to make a conductive textile. This technology will take the wearable technology to the next level, where everything gets integrated within the clothing without changing the drape and handle of the textile. Here we have two examples of the synthetic material and non-synthetic fabric. You can see here with this demo, which is an LED on the top and a battery at the bottom. You can check the circuit. You can see the light is coming on, so that shows that the circuit has been formed. And when there is a track, then on here you can see there is a light coming on when the track is there. And when you go to the part which is non-conductive, then the light doesn't switch on. So you can see that the drape and the handle of the material has not changed. So still the fabric is a fabric. And in this case, it is quite stretchable, but still it works. So I can demo it for you. Here you can see the light is still on, but the part which is not conductive, the light doesn't come on. As an example of this technology, we've been recently working on the glove for demonstrating the technology. The glove tracks will be running down the fingers, and we'll be able to measure the resistance changes as you move your fingers. This is a glove which has been printed on using inkjet printer. You can see that the nanometal layer is being neatly and accurately deposited on all the fingers here. And at this stage, the electrical resistance of the track is still very high. So you need to move to the next step, which is the plating, to thicken up the metal layer to reach the conductivity that you desire. The metal layer, as you can see, only gets attached to where the nanometal seed layer is. And you leave it in the plating bath until you reach the thickness that you desire. In here we have the cotton glove, but you can use this method for different type of fabric: synthetic, natural, knitted, woven, non-woven, and any type of material that you wish. And still it will plate on the selective part which you already put the nanoseed layer. After plating, to prevent the oxidation of the metal, we do the finishing part, which is the passivation. You can also attach the connection wires here prior to electroless plating, so that everything can be plated as one unit and a solid joint can be formed. Now that the tracks are finished, now it's a matter of connecting it to the microcontroller with a power source, which is the battery. Now we are able to visually monitor how the resistance changes as you bend your finger. Here you can see from the monitor that as my thumb starts bending, the graph shows that the resistance starts lowering, and as I move up, the graph starts going up. The glove is an example of what this technology can do. But there are a range of possible applications, for example, across the sports, fashion, and healthcare sectors. Thank you for listening.